Well, the slope of a nonlinear function actually, it's going to be, that doesn't quite make sense because a nonlinear function is going to have lots of different slopes. So for instance, if you look at this, this graph right here, this is not a line. And so what is the slope of this line? Well, it doesn't have one slope. It has a bunch of different slopes. So we have this term we call the average rate of change. Now the average rate of change, you need 2 points. So let's pick this point right here. If you notice, this point is so -1, -2, -3. This is -3, -1. So here's a point on the function. Now you need another point. So let's go up here to 3, 2, 3, +2. So this function has an average rate of change from this point to this point equal to the slope of the line that connects the two. So the line that connects the two is somehow like approximating this function, and it's giving you a sense of the change, but this function obviously is doing lots more changing around here. So we call this average rate of change, we'll just call it average delta for the moment. It's the change in y, so in this case it would be 2 minus a -1 over the change in x, 3 minus a -3. And so up top you get 3, on bottom you get 6. So we'd say the average rate of change is a half, just like that previous line had slope of a half. This function has an average rate of change of a half. So it has a positive increase, although we can see that there are times where it actually has a negative slope or negative decrease. But on average, this function between this point and that point has an average slope of positive a half. So you might want to say, what is the change in the number, the average change in the number of participants over that time frame? Kind of like average change per year is what we want to compute. So the average rate of change from the year 2000 to 2013 would be a change in the y coordinates divided by the change in the x coordinates. Let's get out compute our slope here. Now our line is going to start there at the 2017.2, and it's going to go up here to there. So our approximation is this line through here. It's approximating the slope of this non-linear function. So let's compute it. So you get 47.6, and you subtract your 17.2, divided by, now the denominator is going to be a little easier, 2013 minus 2000. So we'd say the average rate of change is the change in y over the change in x. So let's get out our calculator. 47.6 minus 17.2 is 30.4. Divided by, well, the denominator is pretty easy. That would be 13. If you take that and you divide, you get 2.3. Now, the units here are actually important because this is an application. We're trying to make an argument, make a statement to help make a policy decision, perhaps, in this case. So the answer here is not just 2.3. It actually means something. It's 2.3 million participants per year. So there's an average change of 2.3 million participants per year. Obviously, from the year 2000 to the year 47.6. So it's not exactly a change in 2.3 million every year, because there was even a decline here in the middle. So, but on average, each year saw an increase in 2.3 million participants. Thank you.